Welcome back to another episode of a question a day will keep a low ATAR away. Today we are talking about one of the last applications of networks. So it's called minimum spanning trees. I think out of all of them, it's probably the easiest one. The way that I think about a minimum spanning tree is I think about electricity, and essentially what you want to do is you want to connect every single point together, and then if you turn on the electricity, everything should light up. Okay, nothing should be left out. But the minimum spanning tree is the shortest way I can connect everything all together. Okay, so let's take a look at this question. The network diagram shows the travel times in minutes along some of the roads connecting multiple different towns in New South Wales. Draw a minimum spanning tree. There's your key minimum spanning tree. Sorry, that was a horrible underline. And so the first thing that I would do with a question like this is I would actually just quickly map down. So that's Dubbo, that's Wellington, that's Peak Hill, that's Grenfell, that is Young, that is Cowra, that is Blaney, that is Bathurst, and that's Orange. Okay. And what I'll do is I'll plot all your points first. Now, generally, your general rule of thumb is start with a point that is fairly connected. And if there's any points that are more connected than others, that's where you would start. So I can see here that Grenfell has a degree of 4, which means there's 4 bits coming in and out of it. 1, 2, 3, 4. There's a couple other 4s here. I could go Peak Hill as well. But I would start with one of those 2 points because I think everything else has only 3. So what I'll do is let's start with Peak Hill. And looking at that, what we want to do is let's connect what looks the shortest. So from Peak Hill, I can see from Peak Hill to okay. This would be interesting. So Peak Hill to Dubbo, I can see the easiest way to connect that would be the 48. And then I'm just going to start with there. So I'm going to connect these two, and that's going to be 48. And then I'm going to look, what's the shortest way to get from Grenfell to Peak Hill? And I can see it's quite high. So for the moment, I'm going to leave that be because we might just connect it through this side here. But let's continue on. So I've connected Dubbo. And then what I want to figure out now is, should I connect? I'll have to connect to Wellington through the 36. That would be the shortest way for sure. All right. Now that I don't need that 78. I know 78 was shorter, but it wouldn't have connected Dubbo, so I'm not going to count that 78. Okay, now continuing on. Let's see. I can do that one. Let's see, from Orange, I can see that there's 32 and 27. So I think those will be the shortest ones. So from Orange to Blaney, that will connect 32 and also 27 from Blaney to Bathurst, because those are my smaller numbers. And so you can see I'm starting to connect everything, but there's not everything connecting yet. From Cowra and Blaney, I think 47 is looking a bit shorter than what my other options, 67, 108, and 98. So I'm going to connect that with the 47. So Cowra to Blaney. Did I miss Cowra? Oh, it turned into a circle. So that should be C. My bad. So Cowra and Blaney will connect via 47. And then looking at here, what's the easiest way to connect in Grenfell? Grenfell to Young will probably need 38 is nice and short. So I'm going to connect that in, and then I will need to connect in Cowra. And by looking at it, I think 40 is a lot shorter. That's going to be 40. And then so now we're just trying to figure out how to connect Wellington and Orange. So essentially what we want to do is we want to connect all of these. Now I can see here between 98 and 108, 98 is shorter. However, if I connect Wellington and Orange, and as you can see, if I just connect those two, everything connects. So Wellington to Orange, I would connect those two. That's 67. And that there would be my minimum spanning tree for this question. How do I find the minimum length? You just add them all together. 48 plus 36 plus 67 plus 32 plus 27 plus 47 plus 40 plus 38. Add it all together. Length, and technically it's the minimum length as well. It should be 335, and I believe this is kilometers. Oh, minutes. Okay, glad we read the question. Okay, that's the minimum length of the spanning tree, 335 minutes. And I think that's it. Now there are some other questions, so let's take a look. It's going to be very similar. It says here the network diagram shows 9 towns and the 15 roads that connect them. The length of each road is shown in kilometers, and all the roads need to be resurfaced after heavy rainfall. The local council decides to initially resurface the minimum length of roads that will allow all towns to be connected by resurfaced roads. This is equivalent to finding a minimum spanning tree. Boom, there's your key question. Determine the minimum spanning tree and find the total length of the roads to be resurfaced. Then redraw the minimum spanning tree on the vertices below. So very similar. This is going to be one of those questions where I'm going to start with the most connected, which in this case looks to be probably V. 1, 2, 3, 4, 5. 1, 2, 3, 4. Yeah, it'll be V. So I'm going to start with V. Okay, now looking at this, 9 and 10 are probably your shorter connections. So I'm going to go V to U. That's the shortest way to connect those two. V to W. That's the shortest way to connect those two. And I can see here that there's 16, but I can see that 7 is a nice short way to connect the X and the Y. So I'll probably do that. And the closest way to get the UVW connected to the XY is going to be via that 15. So I can see here that 15 is my shortest option. And so now I've connected everything on this side here. Now looking to connect the rest, I've got 12, 13, 14. 12 is looking to be the shortest. So I'm going to connect the U and the S by 12. And then from here, let's see, I can connect the 8. Yep, I'll need to connect the 8 in because 8 is shorter than 15. I'll connect from S to R. I would have to connect it probably through the 9 because that's the shortest. And then from your Z to your T, the shortest one to connect that in would be 10. And you can see now everything's all connected. So the length of roads to be resurfaced, add it together, 9 plus 10 plus 8 plus 12 plus 9 plus 10 plus 15 plus 7. And it should be 80 kilometers worth of roads. Okay. There it is. We've redrawn it. That's worth your 4 marks, which is very, very generous compared to this one. I think the first question was a lot more tricky. But hopefully that helps, and I'll catch you guys in the next one. See you later. Bye.